If m is equal to the square root of 4 plus the cube root of 4 plus the fourth root of 4, then the value of m is, so let's see, so we need to estimate what m is equal to. And so cube roots and fourth roots don't appear that much on the Gmat. How would you go about estimating this? So what is the cube root of 4? So that is some number when multiplied by itself 3 times is equal to 4. And so it is obviously going to be a decimal, so I don't know what that is. And I don't really know how to estimate it. I know what square root of 4 is, so I know that is equal to 2. And so now I really need to think about this. So what do I know about both the cube root of 4 and both the fourth root of 4? Well, I know 2 cubed is equal to 8, so it can't be 2. And I also know it must be greater than 1, because imagine that if you had something, if it was 0.99999, well, then that would be 0.999 times 0.999 times 0.999 is equal to 4, but that's never could happen, right? Because here it's like taking 99.9% of 0.999 and then doing it again. And so this number here is getting smaller. So if we need to get to 4, we at least need a number that is greater than 1, and that is actually enough to answer the question. So the same will be true when we take the fourth root of 4. That's got to be something greater than 1. So the fact that it's 2 plus something greater than 1 plus something else greater than 1, that automatically puts you at E as your answer. Another way to think about it is, so if we want to estimate what the cube root of 4 is, so we can think to ourselves, well, what perfect cubes do we know? Because it's got to be between those. And so the cube root of 4 will be in between. So 1 cubed is 1, 2 cubed is 8. So that's too far. So it will be in between the cube root of 1 and the cube root of 8. Which means the cube root of 4 will be between 1 and 2. So this is telling you it's greater than 1, which is all you need to know. And we also know, so 4 is closer to 1 than it is to 8, so it's going to be a little bit closer to the 1 than it is to the 2. So you can say, I don't know, it's 1.35 or something. But again, that doesn't really matter. And you could do the same thing with the fourth root. So what perfect fourths do I know? 1 to the fourth is 1. 2 to the fourth is 16. So the fourth root of 4 should be in between the fourth root of 1 and the fourth root of 16. And so here our range gets a little bit wider, it seems, but this is still good enough to tell us that the fourth root of 4, it's got to be between 1 and 2. And again, so 4 is closer to 1 than it is to 16, and it's a lot closer to the 1. It's a lot further from the 16, I should say, than 4 is from the 8. So this will be, it's still greater than 1, but it will be, 1.1 or something. I don't know. Doesn't matter. As long as it's greater than 1 is all you need to know. So if you ever need to estimate, the only square roots that I memorized really are square root of 2 and square root of 3. In terms of their decimal form, square root of 2 can be approximated as 1.4. Square root of 3 can be approximated 1.7. Those are worth knowing. Anything else, you can sort of estimate this way. So this will work for square roots, cube roots, fourth roots, doesn't matter. And what is this? That should be a cube root of 8.